In this video, we're going to introduce an important rule in differentiation called the chain rule that helps us find the derivative of a function that turns out to be the composition of functions. But before we go into the chain rule any further, it would be probably helpful to go over a brief reminder of what it means to be the composition of functions. So let's consider two functions. Let's say let f of x, little f of x, be the square root of x. And let's change colors here a little bit. Let's say g of x is equal to x squared plus 1. And we want to find, for instance, the composition of those two functions, f and g. So let's consider capital F of x as the composition of little f composed with g of x. And the way you read this is capital F of x, or just f of x, is f of g of x. F of g of x. Now, the way we interpret this is the f, outer function here, the little f, is the square root formula. So we're going to use this formula. Let's change it to yellow. No, it's really green. So little f of x equals square root of x. So this tells us to use the square root formula. We have the square root of x. Now, wherever there is an x in the square root formula, we want to substitute it with a g of x. So if we had, for instance, the square root of x plus 1, we would have inside here the square root of g of x plus 1. But since we just have an x, we substitute g of x wherever there's an x. So we have just the square root of g of x. Now, we want to go a little further. So f of g of x is the square root of g of x, which is the square root of, and the formula for g of x is simply x squared plus 1. So this is f of g of x. Well, what if we wanted to go the other way? We wanted to find, say, g, little g, of f of x. Are those two the same? Are they equal? It turns out in general, you might remember from pre-calc or from college algebra, this is not in general, they are not equal in general. F of g of x is not the same as g of f of x. They can be equal if in fact g and f are inverses of each other. But for now, let's just focus on the composition of these functions. So now the outer function tells us the formula. So this tells us we're going to use the formula for g, which says square something and then add 1. We want to square something and then we want to add 1. So what we want to square is whatever is inside those parentheses. We want to square f of x. Square f of x, then add 1. So let's square f of x. If we square f of x is just the square of x. So we're using this formula for f of x. If we have f of x is going to be squared, and then we're going to add 1. So the square root of x, and then square it, is simply x, and then we add 1. So this is g of f of x. And up here, we have f of g of x. So this is going to be our focus because we're going to look at an example where we want to find if we're given f of x is the square root of x squared plus 1, we want to find f prime of x. What we're going to need to do is we're going to need to show that f of x is equal to the composition of f of g of x, where f is the square root function, f is the square root of x, and g is x squared plus 1. That's the key here. If we start off with a function like capital F of x that turns out to be the composition of two functions, and this is where we need to, sometimes we have to be able to pull apart this function and find out what the two individual building functions were, like f and g. But once we split those apart, then we have a formula for f prime, capital F prime of x. And this is the formula here. So let me bring back all this scrap work here. And that will help us organize. So here's a summary over here of what we just did on that previous screen, where we had capital F of x equals f of g of x. This is another way to write it, by the way, f of g of x. And here's our traditional way, f of g of x. So we had x, the square root of x was our little f, x squared plus 1 was our little g, and then capital F was f of g of x, or the square root formula from f, and we put in g of x, that's the square root of x squared plus 1. Now, this is the way that's going to be more helpful for us when we're given a calculus problem to find the derivative. We're going to be given, for instance, this function. We're going to be given capital F of x equals the square root of x squared plus 1. And we want to be able to show that it was built by these two sort of smaller functions, if you will, where little f of x was the square root of x, and little g was x squared plus 1. So here is our example. This is what you would be given in your calculus problem. Starting off with some function, capital F, or it could actually be written little f, is the square root of x squared plus 1, and we want to find the derivative of this function. It's going to be helpful to note that capital F of x is the composition of two functions, f of g of x, where f is the square root function, and g is x squared plus 1. And now in our formula, here we're finally going to get to our formula. Our formula for f prime, our capital F prime, is f prime, little f prime, of g of x times little g prime of x. So there are two parts. The first part is taking the derivative of the little f and then substituting little g. Then we just multiply times little g. So we're going to have to find f prime first. So let's find f prime. Here's f, little f, is x to the 1/2. So little f prime is 1/2 times x to the 1/2 minus 1, or 1/2 x to the negative 1/2. And that's 1 over 2 times x to the 1/2, or finally 1 over 2 times the square root of x. This is our little f prime of x. But we need little f prime of g of x. So what we want to find is little f prime of g of x. So that means we need to substitute. We're going to use the formula for f prime. The formula for f prime is 1 over 2 times the square root. But instead of x, we're putting in g of x. And g of x is x squared plus 1. So that equals 1 over 2 times the square root of x squared plus 1. That's the first part. That's the f prime of g of x. So we're done with that. Now we just get the easy part is g prime of x. So g prime of x is just the derivative of little g. So now the formula tells us this is g prime and this is f prime of g. And the formula up here tells us that we just multiply those two. So the final answer here, let's pick the color we want to use for now. Purple. So f prime of x is equal to this first part times this second part. So 1 over 2 times the square root x squared plus 1 times the derivative of g of x. And we can simplify just a little bit. These cancel. And so we're left with x up top over the square root of x squared plus 1. And there's our answer. This expression is the derivative of our original f of x. I hope this helps clear up a little bit about the chain rule. We'll take another look at some further examples in later videos.